Okay, so the next gas law that we're going to talk about is Dalton's law. Again, so we're going to look at Dalton's law. I will just say, we've got the three so far, Boyle's, Charles, and Gay-Lussac's, but really you can consider it as one combined, and then whenever there is no change in one of those three, cross that variable right out, and then you've got whichever law you've got to use. Dalton's law is completely separate. It's on its own. Dalton's law, and again, I've been showing some pictures and talking a little bit about the gentleman. Dalton is an Englishman. All right, let's have enough of that. John Dalton. So Dalton's law deals with this. In a mixture of gases, so if you have a whole bunch of different gases, the total pressure is the sum of all the partial pressures of the gases. I sometimes say it's, how's this guy get his own law? It's as easy as saying, let's add up all the pressures. That's the total pressure. And that's exactly what it is. So let's say we have a balloon, okay? We got a little balloon that has nitrogen in it, and it has carbon dioxide in it, and it has water vapor in it, let's say, and how about some oxygen? Okay, it has 4 different gases. Well, if there are partial pressures, if the nitrogen's pressure is 1.25 atmospheres, actually I have some, what did I do here? Let's go ahead and do this. 1.25 atmospheres. Let's say the carbon dioxide is 750 mmHg. The water is 101.79 kPa, and the oxygen is 1.45 atmospheres. It'd be a pretty strong balloon if it has all those types of pressures, but it could be a tank, whatever. Here's all your partial pressures. If I want to know the total pressure, it's simply adding those all up. So Dalton's law basically is this: the total pressure is equal to all the partial pressures added up. And I'm just going to put ... Let's say you only had 3 there, you'd be done. If you have 4 in this situation, you'd add the 4th. Okay? Now on purpose, if you don't mind, let me get a calculator. On purpose, I had different units: atmospheres, millimeters, mercury, kilopascals. You can't just add those all up. It's certainly different units. So in this situation, I'm not asking, which pressure I want it in. So since I have 2 atmospheres, what I'm going to simply do is change the other 2 to atmospheres and then add those 4 up. So I'm a big fan of the X line, mmHg, atmospheres, 760. So I'm going to take my 750, divide by 760, 0.99 atmospheres. And how about this next one? Can you see that green? I think so. kPa, atmospheres, 101.325. So 101.79 divided by 101.325, I get 1.005 ATMs. And now I'm going to add these 4 numbers up, and that'll give me my total pressure. So plus 1.25 plus 0.99 plus 1.45, and I get a total pressure, oops, let's change this to a different color, total pressure of 4.69 atmospheres. Okay, so there's Dalton's law, probably the easiest of the bunch. Only tricks that you can come by is if I change the different units, or how about this, if I give you the total pressure, I give you 1 partial pressure, I give you a second, and I ask for the third. Obviously we would add these 2 up and subtract from the total pressure. But that's Dalton's law.